So next we will discuss about a vane pump. The vane pump is consisting of the rotor on which a number of slots will be there, and these slots are occupied with the help of vanes. So the movement of the vanes into the slots can be done with the help of the centrifugal force, which is done by rotating the shaft. So during half the rotation of the shaft, the oil is going to enter between the vanes, and whatever the gap we are having between the vanes, that will be occupied with the help of the hydraulic fluid. And in the next half revolution, there is a again decrease in the volume. So this decrease in the volume is going to increase the pressure. So because of the squeezing action, the oil is going to be expelled out from the pump. So these types of vane pumps are classified as a fixed displacement vane pump as well as the variable displacement vane pump. And again, this fixed displacement vane pump are classified as unbalanced type as well as the balanced type. Let us see one by one. So in the case of fixed displacement vane pump, so these are the pump in which the eccentricity cannot be changed, in which the eccentricity between the cam ring as well as the rotor, that cannot be changed, because of which we will be getting the fixed discharge, will be getting the fixed amount of the discharge from the outlet line at a particular pressure. So such type of fixed displacement vane pump can be again classified as unbalanced type as well as balanced type. So in the case of unbalanced type, so this is the vane pump, and this is the rotor which is having the radial slots. So these are called as the slots, into which the blue colored one is nothing but that is the number of vanes. So always there will be eccentricity in order to get the suction as well as the discharge. Because of the eccentricity only the pump is going to work, right? So let us see how this type of pump will work. Again, the same pumping theory only we are going to apply here. If you observe from this position, this point to till here, there is an increase in the volume, right? And if you observe from here to here, there is a reduction in the volume. So here in this case, I am considering this as an inlet and this as a outlet, right? So the rotation of this rotor will be in this direction, that is in the clockwise direction, because of which there is an increase in the volume. So this increase in the volume is going to make the reduction in the pressure, because of which the oil is going to be sucked from the atmosphere or from the reservoir into the chamber. That is during the first half revolution, and during next half rotation of the shaft, there will be a reduction in the volume, which is going to make the squeezing action, so that the hydraulic fluid will be expelled from the outlet line. So in order to get this suction chamber as well as the discharge chamber, we should maintain the eccentricity compulsorily, right? So this is the isometric view what we can see of this unbalanced vane pump. And why we are calling it as unbalanced? Vane pump is okay, but why we are calling it as unbalanced means, in this case, this is the negative pressure zone, right? So this is the negative pressure zone. The force will be applied on the shaft, that will be in this direction. That is nothing but it is going to make the pull force which is acted on the shaft. And similarly, this is the positive zone. The positive zone means positive pressure zone. This is also going to make the pressure on this side itself, right? So this is also going to act the force in the same direction as that of pulling force. So the resultant force will be again in the same direction itself, right? So both the directions are same, again the resultant is also in the same direction, because of which there is a failure of this mechanical component or the mechanical shaft. Right? So this is called as the unbalanced. This problem can be eliminated in the next case, that is with the help of the balanced type of vane pump. With the help of, so this is the animation what we can see how the pump will work, vane pump. The extension as well as the retraction of these vanes into the casing can be done with the help of the centrifugal force. And we will discuss these things now itself, right? So this is the schematic 2D diagram what we can use it for explaining. And here DC is nothing but the cam ring diameter. This is the cam ring diameter. DR is the rotor diameter. DR is the rotor diameter, and L is the width. As usual notations, N is RPM, VD is the volumetric displacement, and E is the eccentricity. And Emax is nothing but the maximum eccentricity. How much maximum we can achieve the eccentricity here? So maximum I can achieve, the diameter of this rotor should be at least equal to the radius of this cam ring, right? So the diameter of this rotor should be at least equal to the diameter of the cam ring. That is the maximum what I can achieve. So by maintaining the maximum eccentricity, I will be getting the maximum volumetric displacement. As I said, the diameter of the rotor must be equal to at least the diameter of the cam ring. So that is Emax equals to DC minus DR divided by 2, and the volumetric displacement as we have calculated in the case of gear pumps, in the same manner we will be calculating here also, pi by 4 DC square minus DR square, because whatever the gap we are having between the cam ring as well as the rotor, that space only utilized in order to carry the hydraulic fluid. So it is area, so this is the area pi by 4 d square into the volume, that is into the stroke length, so which will give the volume, that is the amount of volume which is displaced per revolution. I can simplify this one, DC square minus DR square, which is in the form of A square minus B square into A plus B into A minus B, A plus B into A minus B, and instead of this DC minus DR, I will put it as 2 into Emax here. So I will substitute here 2 into Emax, and I will cancel this one, 2 2s are 4. I will get finally VD equals to pi by 2 into DC plus DR into E into L. So that is the formula what we can use in the case of the vane type of pump. And again we are using the same QT formula which is equals to VD into N. And the advantage of using such type of pumps is it handles thin liquid at relatively higher pressure, and it compensates for wear through the vane extension, and it can run even drive for a shorter period of time, which is not possible in the case of gear pumps, and it can have one seal or stuffing box. It also develops a good amount of vacuum. So those are some of the advantages, and similarly the disadvantages are the complex housing and too many parts are there in the case of the vane pumps. It is not suitable for the higher pressure as well as high viscosity fluids. So next one, we have seen the balanced unbalanced one. What about the balanced one? So in the case of a balanced vane pump, it consists of the 2 inlet as well as the 2 outlet. This pink colored one are nothing but the outlet, which are kept diametrically opposite to each other, and the 2 inlets whatever we are having, those are also diametrically opposite to each other, and we are having the elliptical casing here. Inner surface of the casing or the cam ring will be in the form of elliptical in order to get a suction as well as discharge. That is, for one rotation of the shaft I will be getting 2 suction stroke as well as to discharge stroke, right? So in the same manner, the veins are going to be ejected out as well as those are pushed inside. See here, this green colored one is nothing but the inlet, and the red colored one are nothing but the outlet. So if you see here, the green colored one, there is an increase in the volume, so which is going to reduce the pressure. Obviously this reduction in the pressure is going to suck the hydraulic fluid from the inlet line, right? So when it reaches this particular point, the whatever the gap we are having between these veins, which will be occupied with the help of hydraulic fluid, and during the further rotation, next half rotation, there is a reduction in the volume here. So this reduction in the volume is going to squeeze the hydraulic fluid, so that the hydraulic fluid will be discharged from the outlet itself. So this is in the case of the balanced vane pump. Why we are calling it as balanced vane pump? Because whatever the pull force that will be acting in this direction, the same magnitude pull force will be there in the opposite direction. So this force will be cancelled by this force, and the positive force will be there in this manner. The same magnitude positive force will be there from this side also, and these are also going to cancel with each other. So the net effect or the net resultant force will be 0 on the shaft, because of which the life of this balanced type of vane pump will be more compared to the unbalanced type of vane pump, right? So these are nothing but again the same thing, the balanced type of vane pump. This is the 2D sketch of the balanced type of vane pump, and some of the important characteristics we are having, such as the displacement around 200 cm³ per revolution, 280 bar pressure, which will give the fixed displacement, and it provides a prime mover softer start and simple double assemblies, a lower noise, good serviceability, right? So those are nothing but some of the characteristics. The advantages are, it gives bigger flow because of 2 inlet and 2 outlet. It has bigger pressure also, the life is also better, and constant volume displacement. You cannot change the amount of volume which is discharged. And in case of variable displacement, we are going to change the eccentricity between the cam ring axis as well as the rotor axis, so that I will be changing the amount of fluid which is discharging through the outlet line. Let us see how I am going to change. See here, in this case I will be changing the eccentricity, so that I will be changing the amount of fluid which is coming from the outlet. See here, in the first this diagram, I will be having some eccentricity here between the cam ring as well as between the rotor, and this outlet line I will be supplying to this smaller piston, which is going to be acted on the cam ring. When this piston force will be greater than this opposing spring force, in that case the cam ring is going to be shifted towards the left side. That means the eccentricity is going to be reduced. Whenever the eccentricity is going to be reduced, then obviously the flow is also going to be reduced, right? So again, if you are having any amount of higher pressure here, that is again still it is going to compress the spring, and again I will get the lesser again I am going to get the lesser eccentricity, so that, and in the last stage I won't get any flow because both are in concentric manner. There is no eccentricity, that is E equals to 0. So this is how variable displacement pumps will work. Thank you for watching.